Good day, everyone. So, are you struggling in naming binary compounds?
Cause worry not, we got you.
Today, our group will be discussing on how to name the different types of binary compounds. So, tune in to make sure that you learn a thing or two in this video. Let's get started.
The cation or the positively charged ion, which in our example is called potassium, is always named first, and the anion or the negatively charged ion, which is chlorine, is named second. Monatomic cation take its name from the name of the element. For example, K is called potassium in the names of compounds containing this ion, while a monatomic anion is named by taking the root of the element name and adding IDE. Thus, the Ci ion is called chloride, which makes it called the potassium chloride. Now we're done naming the type 1 binary compound, so let's proceed to type 2. Therese?
Thanks, Joshua. So, we are given with lead-2 chloride with its chemical formula PbCl2. And let me walk you through how we arrive at that formula. Pb is the symbol for lead, while Cl is for chlorine. We all know that Pb is a metal, while chlorine is a non-metal. That's why we need to consider their ionic charges. So, lead, that tells us right from its name, has a 2+ charge. So, write that as Pb 2+, while chlorine has a 1 negative charge. And since they are neutral molecules, we need to add up them to 0. And as you can see, they don't right now. And to do that, we need to use the crisscross method, which will be Pb1 will be put into here, and then Cl2 will be put into here. And by convention, normally we don't use 1 as a subscript, so it will be PbCl2, which is the formula for lead-2 chloride. So, let's check our work to make sure we got that right. So, we have here PbCl2, which is our original formula. So, we said earlier that Pb has a 2+ charge, and chlorine has 1 negative. Since we have 2 atoms here, we will multiply it to -1. 2 times -1 is obviously -2, and 1 is a subscript here, so 1 times 2 is 2. When we add up this 2 and -2, it will sum up to 0, and that's what makes it correct. Now, in naming type 3 binary compounds, as our example, we have here trisilicon octaiodide. The first element shown in the compound is named as the element, while the second element shown in the compound is named according to the anion name, ending in IDE. But take note that the second element always carries a prefix indicating the number of times it is present in the compound, and in this case, the second element is present 8 times, so it has the prefix octa. The amount of the first element is present more than once, so you must then specify the number of times it is duplicated, just like what we have here. The first element that we have is silicon, and it is present thrice, so it has the prefix tri. And that's why it is called trisilicon octaiodide. Proceeding to the polyatomic ions, so as we look at the periodic table, cesium has an element symbol of Cs, and the polyatomic ion, which is the acetate, is represented by C2H3O2. So, cesium is a metal, and the acetate is made up of non-metals that is ionic, so we need to get the ionic charges of the two. Cesium has an ionic charge of 1+, while acetate has an ionic charge of 1 negative. And since they both have the same charges, we won't have much problem in writing its formula. And that's why it is written as CsC2H3O2, or what we call cesium acetate. So now, let's proceed to the last part of this video, which is naming acids. Carl?
Naming acid, there is a rule that must be followed to come up with the proper name of the acids. The rule is for negative ion of the compounds that ends with IDE, ATE, and ITE. But what if the negative ion is something different? There is an important exception for the acids like sulfite, sulfate, phosphite, and phosphate. Now, we have this acid as our example and we will name it properly. If we follow the first rule that the negative ion that ends with ATE must be replaced, then our acid will be named phosphoric acid. But this name is wrong, and there's a proper way in naming this kind of acid. Step 1. Breaking it into two ions. Acids are electrically neutral, that makes the charge upon the anion part must be balanced out by the H+. In this acid, we have 3 hydrogens, so it will be 3H+, and the other part is PO4, and its charge should be 3-. It's got to be 3- to balance out the 3H+ that we get from the hydrogen. Step 2. Naming the negative ion. Next, we're going to name the negative ion PO4 3- that belongs to the polyatomic ions. This negative ion stands for the name phosphate, and we can now proceed to the next step. Step 3. Naming acids. The negative ion, phosphate, ends with an ATE, and as stated in the rule, we should get the root word PHOSP and add the suffix IC, and we will make it phosphoric acid. But that is not the proper name for it. The proper name of this acid is actually phosphoric acid, for it to be logically correct. In this rule, we are going to add OR after the root word of the negative ion, and we're going to add the suffix IC that will make our H3PO4 as phosphoric acid.
There you have it. We hope that you learned something from naming acids.
To type 1 binary compound,
Type 2 binary compounds and polyatomic ions. See you again on our next tutorial. Always think protons!